Good. So Conrad chatting about the break now, the midterm break. So we've got the whole of this week in school, and then we've 1 week off, a full week off, Monday to Friday. Okay, and then I think that week starts with the 14th, the week we're off. Now look at me. So we're in this week, 8th, 9th, 10th, 11th, 12th. And then the week starting 14th. Yeah, 15th. So the Saturday and Sunday, 13th and 14th. Then 15th we're off, 16th, 17th, 18th, 19th, all off. And then back to school on the 22nd of February. And then we'll have probably another maybe 2, 3, 4 weeks, and then we'll be back in school. Now, when we go back to school, we will give you the forces test. But do you know what we'll probably do? We'll probably just leave it to summer, and we'll give you 2 or 3 chapters tests all in the one go. But we'll spend time doing a bit of revision before the test. So in the summer, we'll test this forces. Now, I have a fair idea who's got the hang of what from reading your answers, but I still would like you to sit down and do the test that we usually do every second year. Okay, so going back over what we did the last day then, what is a moment? All right. Now, a moment is a turning force. So to calculate the moment, the turning force, we've got force multiplied by distance. Now that's not exactly right. It's force multiplied by distance from the pivot. So, but I'm just shortening that down to distance. Now, you've got a picture of a crowbar. Now, I gave you this example the last day as well. And there's a big heavy stone that they're trying to lift. And you want to work out the turning force of the crowbar. Well, you're going to put the force here, 15 newtons. The distance between the pivot's here. I'll label the pivot. I'll label it P, capital P, for pivot. So the distance between the pivot and the force is 2 meters. So to calculate out the turning force, what is the turning force? You're turning down there, you're turning, this is going up, but you're turning that direction clockwise, is 15 newtons times 2 meters is 30 newton meters. That's your turning force or your moment. Now, so in today's work, there's questions on just that easy, just working out a turning force. Now, going on then to the harder questions, you did some of these last days, are well fit for them. Balancing forces. So is this seesaw balanced? You have 2 newtons on this side at 3 meters, 3 newtons on this side at 2 meters, and you use your equation that you would have to write out if you were doing a test. F1D1, this is F1D1 here, equals F2D2, okay? So hang on, Connor. So we're going to copy that one out. Don't worry about that one. Copy that one out and show me the work in there, and then I'll do it out for you. Now, Connor, do you want to talk now?
Isn't that one not balanced?
Oh, why do you think it's not balanced?
No, I said it is balanced.
Oh, it is balanced. It is balanced, yeah. Oh, but I just want you to show me the working out here to show me that, and then you write is balanced. Is balanced just for this one. Okay, so just copy that out and then show me the working out, and then I'm going to show you the working out just to make sure we're all right. Okay. And when you've that done, Conrad and Saoirse, put your hand up for me. You've done already, Conrad?
Yeah.
You're very fast.
Done it also
Huh?
I've written it out beforehand, so have.
Right. Right, brilliant. That's not the same ones as I did the last day, is it? Am I giving you exactly the same questions?
No, but it looked like the via the one for questions on the PowerPoint, so I just done them and thought it was
Before. So basically what you're telling me is you're good with this. You're ahead of me. All right, so force here 2 times distance 3 equals force of 3 times distance 2. And then Conrad, did you write 6 here equals 6? So 2 times 3, 6 equals 6. And then to the right of it, you write the seesaw is balanced. Okay, happy enough? And then we're on to the last one here on this page. Work out this one. Does it balance? Now, my writing's not that good here. So 10 newtons here and 2 meters. And 4 newtons here and 5 meters. So you're doing the same thing again. You're doing the same thing again. Can you see that all right? So, Kate, we're going back over, Kate, what we did the last day. All right. We're doing some more calculations on it. Okay, Kate, but I've been recording this lesson. So what you've missed for the last 5 minutes, you'll be able to view it at the start. So Kate, just if you've got your book there to copy out the notes, we're on this question. So hang on, I'll draw a line there. Go, somebody. Okay. I know it's Conrad. It is balanced, good man. So we're on this bottom question. Kate, so I don't know if you can keep up with what I'm doing here. So just copy that out. 10 newtons at 2 meters and 4 newtons at 5 meters. I'm sure Saoirse's busy doing this, or might have it done. Okay. And Kate, when you get that copied out, you put your hand up and let me know and I'll go on ahead. Because Conrad's done and I'm sure Saoirse's done. Good girl, Kate. So, my arm's getting sore from holding this up. So we're going to do, Kate, I don't know if you were here the last day, F1 times D1. That's the moment on this side equals F2 times D2. That's the moment on that side. Now, if they balance, if they're the same, then your seesaw is balanced, but we want to work out, is it balanced? So we're putting in for force 10 newtons. We're putting in for distance 2 meters. And on the other side, we're putting in for force 4 newtons. And we're putting in for distance 5 meters. And then we're doing our sums. 10 times 2 is 20 equals 4 times 5 is 20. And then we're going to write is balanced because the turning force on this side is 20 and the turning force on this side is 20. Now, on this side, if it was turning, we'd lie drawn an arrow. That Newton would be pulling down on this side and trying to turn it that way, clockwise. This would be pulling down on this side and trying to turn it that way, anti-clockwise. So we call these the clockwise moments and we call these the anti-clockwise moments. So clockwise moments, CWM, and I've done that wrong. That's anti-clockwise. And on this side, clockwise moments, CWM. So AWC, anti-clockwise moments, equals clockwise moments. The seesaw is balanced. Okay, now in the ones that I've put up for your assignment, I haven't put it up yet, I'll put it up now after this, they're not all going to be balanced. So if you get the clockwise moments and the anti-clockwise moments and they're not equal, then you write not balanced. Okay. Now, Again, we did this the last day. I've just put up more questions on it today. I haven't given as many examples today. So the seesaw is a lever. It uses these balanced forces, these moments, turning forces. And you're lifting up here, so the force is drawn up there. The weight of the load is acting there, so we're drawing an arrow there. And that where everything else moves around it, but it stays still, is the pivot. And in today's work, you're being expected to label the pivot and the forces. I tend to call this force the heavy, force the load. Now, and the next thing I show you, that's going to be called the weight, but forces get called all kinds of different things. You just need to get used to that. And the upward force here, the lifting force, that's bringing the wheelbarrow up. Okay. Now, I was in a quiz last night, and one of the questions was, what did Aristotle say about levers, these turning forces? And what he said was, if you give me the longest crowbar, I can lift the world. So basically what he's saying is we can lift any force if we've got a long enough turning force. You'll be able to lever it up. Now, of course, he was exaggerating, but it went down in history as being a really important quote, and just happened to be relevant to this, was in the quiz last night. Now, I'm going on to the calculations again that you can do, but there's more of them in today's assignment. So, I don't know, Kate, if you get this copied out from the last day. F1D1 equals F2D2. So we're turning the moments, the turning forces that we've done, into a straightforward calculation. F1 times D1 equals F2 times D2. And there I have that written up. Anti-clockwise moments equals clockwise moments. ACWM equals CWM. Okay, I think you definitely have that written down because I made a copy down of a PowerPoint for the last day's assignment. Okay, now this is page 4 for today's work. So more of these calculations. So I want you to copy down number 1. Don't bother with number 2 yet. And then do your working out and then put your hand up whenever you've it done. So copy that down, do your working out, and put your hand up when you've it done, and then I'll do the working out with you. Okay, do that now and put your hand up when you're done. Oh, you mightn't be able to see it. We're only doing number 1. Okay, so put your hand up. Kate's her hand up, so put your hand up when you've it copied out. You're only copying out number 1 for me now. Okay. Conan's copied out now. Okay, so you should put your hand up when you've copied out. Good, Garrett. Okay, you can put those hands down. So we're just looking at number 1 now. Okay, put the hand down, Conrad, unless you want to ask me something. Good man. So how are we going to work this out? Well, we're going to do F1D1 on the left. And then on the right, it's clockwise moments, F2D2. So the first thing you always do is copy that out. Conrad, do you want to ask me something? You've got the answer ready. That's what you want to tell me. Okay. Now, what is our F1D1 on the anti-clockwise side? Conrad, yes?
I wasn't saying that, so I wasn't. The hand up was by accident, so it was.
Okay, come on. All right, F1D1 on the anti-clockwise side. So what's our force on the left? 4 times what's our distance on the left? 5 equals. And what's our force on the right? 2 newtons. What's our distance on the right? We don't know. And that's what we have to find out. So we're writing it down as being D2. Okay, now we're going to work out what we know on this side, 4 times 5. We're going to write that down. All right, so go on ahead, 4 times 5, you can do that in your head, equals 2 times D2. Now, we want to work out D2. We need to make D2 the subject of the formula. So making it the subject of the formula means get it on its own. So we want to get D2 on its own. Keep the 20 over here. What do we have to get rid of here? Well, we've got D2, we've got a 2 as well. So we're bringing the 2 across the equal sign, and the 2 will become dividing. The rule is, if it's multiplying on this side, and you bring it across the equal sign, it will become dividing. Let's say it had been dividing on this side, and you bring it across the equal sign, it will become multiplying. Now you can see here now I'm doing 20 divided by 2. I'm not putting in that divided sign that you would use in maths. I'm doing it this way. This is how we do it in physics. If you did put in the divided sign, you would get full marks. But we just don't write it out like that in physics. So you can easily do that in your head now. D2 equals 20 divided by 2 is 10. And you could have done that up here. 4 times 5 is 20. What times 2 would give you 20 is 10. But they're not always as handy a numbers as that. So you have to be able to do the working out. I know this is quite difficult for year 9, but it's nice to get something a wee bit challenging during lockdown. So we're on to number 2. I want you to copy down number 2. So you've copied down number 1. I want you to copy out number 2 and then put your hand up when you've been copied out. Okay. Okay, so we're going to work this one out. But if you've got it already written, copied down, and you're waiting for the others to copy it down, you go on ahead and write out F1D1. F1D1 equals F2D2. Good girl. So go on ahead and write out F1D1 equals F2D2 for this one. Okay. Connor, are you ready yet? So I'm writing F1 times D1 equals F2 times D2. Now go on ahead and see, can you fill in the next line? See, can you substitute in the correct values? Make sure you're doing on the left here and on the right there. Now on the left is your anti-clockwise moments and on the right is your clockwise moments. So we're substituting in what we have. So on this side, F1 is 10 and D, the distance is 4, D1. And on this side, F1 is 8 and the distance we don't know. Now, if we don't know it, we're going to keep it as D2. And that's what we have to work out. That's the question mark. Go on ahead, see, can you do the next line? 10 times 4 is going to give you, do that in your head, equals 8 times D2, nice and tidily like that. So we've got worked out 40 as being the anti-clockwise moments, and we now need to work out what D2 is here. Well, if the anti-clockwise moments are 40, then the clockwise moments are also 40. So 8 times D2 gives you 40. And I know you could work out in your head, 8 times what gives you 40? I know you can work that out. Okay, so we know what the answer is going to be, but we want to get D2 on its own. We want to make D2 the subject of the formula. So we want to get D2 on its own, we need to get rid of the 8. And the rule is the 8 is multiplying on this side. When we bring it across the equal sign, it's going to become divided. So it's 40 divided by 8. So D2 equals, and you would put that into your calculator, 40 divided by 8, or do it in your head, and we're going to get a distance of 5 meters. All right, so we're on to number 3. Okay, put your hand up if we're ready to go on to number 3, or if you need me to put my page back up again, put your hand up if you're ready to go on to number 3. Good. Everyone? Good. Good, good, good. Put your hands down. Okay, hands down. Okay, hands down. Number 3. I'm putting it up for you. Now this time we're being asked to find the force on the anti-clockwise side. All right, Conor, do you need help?
No, but I can't get it down.
It's all right, don't worry about it. I know you got it now. All right, so we're all on 3. Copy that out. And then go on ahead. It's exactly the same thing, except we're working out F1. So keep F1. Don't fill in a value for F1. Keep F1 as F1. Okay. Okay, put your hand up if we're ready to do the calculations. Conrad, your mic's on again. Okay, Keisha, should we ready? Okay, so you're writing F1, good girl, F1 D1 equals F2 D2. F1 D1 equals F2 D2. Okay, and then substitute in your values for 3. So for F1, we're not going to put in a value, we're going to keep it as F1. Put in the distance. Okay, 10.5 equals, what's your F2? 6 newtons. And your D1 is 7 meters. Now, what can you work out? Are you able to work anything out there? Can you do the 6 times 7? Okay. Do they know that in their head, I wonder? It's 42. And we want to work out what is 6 times 7? 42. It's half 21. 10 minus 5. Right, it's okay. I've done it right. I was doubting myself there. So we want to work out what F1 equals. Now you can see I've made the numbers a wee bit harder for you now. Okay, come into your ahead of me. I'm going to say you're right. Oh, hey! What are the rest do you think? Post up your answer there if you think you can get it, Kate or Saoirse. So here's your good girl. Hang on, I have somebody waiting in the lobby. Amy, hang on. I need to tell Amy to try again. Okay, so we want to work this out, and you might need a calculator here, but you're saying what times 10.5 will give you 42? Okay, now if you had a calculator, you would get F1 on its own on one side of the equal sign. So that means we have to get rid of the 10.5. The 10.5 comes across the equal sign. It's multiplying here, it becomes dividing. Bring it across, it becomes dividing. You put that into your calculator. 42 divided by 10.5 and press equals, and your calculator should give you 4. And that's force, so put capital N for newtons as your unit. Okay, now you might have needed a calculator, or your algebra, your mental maths could be good enough to do that without the calculator. Okay. Well done, year 10, year 9. Okay, last wee bit. Now I'm only going through Newton's laws here because it's the next page and I want you to work on it for the rest of the week. But I'm posting an assignment up for today with calculations the same as today's. Now you might need to make some notes on this. Newton's laws. So Newton, he made up a law and said that if the forces are balanced, if the object is stationary, it will remain stationary. I've written here's a bullet point, it will stay still. Or if it's moving, it will continue to move at a steady speed. Now I've drawn up an object with balanced forces. There's a forward force there, which could be engine force or forward force or push. There's a backward force here, which could be air resistance, friction, some kind of a backward force, pull. So there's loads of different names for forces, so you're just going to have to figure them out, guys. And these are Newton's 2 laws. Now they're in the second worksheet, the finishing worksheet for this week. And it'll show you lots of little diagrams with balance and forces. Now sometimes the forces are balanced like this, and sometimes, as you can see down there, they're not balanced. Now if they're balanced, the object will remain still, or if it's moving at a steady speed, it will continue to move as a steady speed. Now let's say it's going at 40 meters per second. It'll keep going at 40 meters per second if the forces are balanced. Now, down here, I'm showing you some balanced forces. So this is an object with a push of 50 newtons and a pull of 50 newtons, so that's balanced. This is an object with a push of 20 newtons, but a pull of 40 newtons, and it's not balanced. Now, could you work out the overall or resultant force there? What is the overall force? Well, there's 40 going this way. Think of it as like a tug of war. 40 going this way, but 20 of the 40 is being cancelled out, and that will leave you 20. So it's 40, take away 20, leaves 20 is the overall leftover force. In this next example, it's not balanced. There's a forward force of 30 and a backward force, a frictional force, a resistance force of 10 newtons. So how are we going to work out the overall or resultant force? We're going to take our forward force and subtract our backward force to give us what the leftover force is. Think of it as a tug of war, and there's 30 people pulling this way and 10 people pulling that way. That's leftover of 20 people, because you've got your forward force, subtract your backward force. So that's 30, take away 20 equals 10. No, it's 30 take away 10 equals 20. All right, so the leftover or resultant force will be 20. What about for the bottom example? Because sometimes you don't just have one force going in each direction. So you've got a forward force of 60 newtons, but look at, you've got 30 newtons cancelling out the 60 newtons there, 30 newtons cancelling out the 60 newtons there. So there's a total backward force of 60 newtons. So 60 newtons this way, 60 newtons that way. They balance and cancel out. Now, if I were to do the same subtraction there, forward force 60, subtract the backward force 60, be 60, subtract 60 equals not 0. 60 subtract 60 equals not newtons. So there's no overall or resultant force in this bottom example. Now, that's a wee bit of an introduction for your that sheet. I haven't posted up an assignment on that sheet, but I will tomorrow. That's that sheet there. So you've done that sheet. I've work up for you today, and that's tomorrow's work. So that's going to be 2 assignments this week, and I'll correct that later in the week, and that'll finish us. And then a full week off for midterm, and then back after midterm in the 20-something, whenever I said that was. So today's the 8th, it's this day fortnight, 8 and 14 is 22, back on the 22nd. All right, guys, well done, excellent work. I'm going to finish recording that, and then if you have anything to ask me, that's that stopped recording in case. Now, are you able to, you guys able to see able to play the recordings?